Imagine a space wanderer from a distant star system, drifting for maybe billions of years, and now he's crossed the border of our solar system. This is 3I Atlas. This March, astronomers already realized that 3I Atlas is not just a comet from the Kuiper belt or the Oort cloud. Its orbit is clearly hyperbolic, meaning it came from interstellar space. Scientists speculate, perhaps this object formed in a star with a low content of heavy elements, a low-metal star, in the thick disk of our galaxy. Its age is estimated to range from several to tens of billions of years, making it potentially older than our solar system. Scientists believe it was ejected from its home star system by gravitational interactions, such as a giant planet, and has drifted through interstellar space until it entered our solar system. Here are some new facts that are not often covered. In August of this year, data were obtained using the James Webb Space Telescope infrared spectrum. In the Comet 3I Atlas, it was found that the ratio of CO2 to H2O of about 8:1 is one of the highest values among known comets. This could mean that the comet's nucleus was originally rich in CO2, or that its water activity is suppressed, for example, due to a thick layer of surface ice or crust. In August of this year, emissions of hydroxyl radicals were also recorded, indicating the presence of water even at a distance of about $3 from the Sun, a place where water usually evaporates weakly. This suggests that 3I Atlas is active much farther from the Sun than the usual comets of the familiar solar system, possibly due to the presence of large water flows in the cloud of gas dust around it, which evaporate as separate parts. In September of this year, polarimetric studies showed that the coma shows deep and narrow negative polarization, up to is almost equal to -2.7% at a phase angle of 7 degrees, and an inversion angle of about 17 degrees. What it means: 3I Atlas differs in its light reflection properties from many comets in the solar system and is possibly closer in its properties to trans-Neptunian objects, or Centaurus. Another extremely interesting aspect. Scientists in October this year note that the surface of the comet may have been greatly altered due to billions of years of cosmic irradiation. According to the pre-publication, an outer crust of the order of 15 to 20 m thick could be transformed, for example, CO2 by irradiation. This means the outer layer of the comet may no longer display the raw composition of its formation, but be polished by time and irradiation in interstellar space. Let's get to how she behaves. This October, as it approached the Sun, 3I Atlas suddenly intensified brightly. Its brilliance grew faster than expected. Scientists do not fully understand why. Perhaps the sudden release of large amounts of ice or dust, or changes in the structure of the core. Despite media expectations of a color change of the comet, a study published in November this year found that there is no conclusive data that the comet changed color. Its dust and core look perfectly blue in relation to the Sun, although the dust previously looked redder. One interesting point: it is predicted that it will not pass too close to Earth, at least 1.8 AU. Some scientists have suggested that the comet's activity may be due to CO2 sublimation, which ejects large water flows that then evaporate at a distance of 3-4 AU and give a significant visual reflection effect before the ordinary tail of ice and dust begins to dominate. That is, at first, the comet glows not with a classic tail of dust, but with ice flows ejected by CO2 sublimation, an interesting distinguishing feature. And here are the most exciting moments. There is a group led by Avi Loeb which argues that some features of 3I Atlas, for example, unusual chemical composition, behavior, possible non-standard form, can be explained not only by natural processes, but also by the possibility of an artificial origin, for example, by a probe of an alien civilization. However, most astronomers believe that there is no reliable evidence of an artificial origin. All the data can be explained by natural processes. although some remain a mystery for now. The big news: a new model has been proposed that for interstellar comets you need to take into account not only their formation, but also billions of years of drift in interstellar space, including irradiation, micrometeorites, radiation. This model changes the approach. You can't just think of such objects as raw analogs of comets in the solar system. Another question is where it goes from here, and how many of these objects still fly close to the solar system without being noticed. A new study indicates that one part of the Earth may be slightly more susceptible to impacts from interstellar objects. 3I Atlas provides a unique glimpse beyond our solar system to see material formed around another star. Given its unusual behavior and composition, it turns into a natural experiment that helps astronomers understand how diverse the materials of planetary systems outside our own are. If its outer layer is indeed greatly altered by cosmic irradiation, it means that when we study other interstellar objects, we must be prepared for the fact that they can be reinterpreted by the processes of galactic evolution, not just preserved babies of their time. New observations have been made, and it is expected to become visible again after it emerges from the obscuration of the Sun. This will allow for even more data on spectrum, trajectory, and activity. More broadly, such facilities stimulate the development of surveillance technologies and analysis methods. Despite the massive data, we do not know the exact size of the 3I Atlas core. Estimates vary widely. Exactly why CO2 is so dominant is not yet fully understood, either through formation in a special environment or through the subsequent suppression of water activity. What her native system was, and how long it has been adrift, we can't reconstruct exactly the path. How much of its behavior, bright amplification, icy particles at great distance, is common to interstellar comets in general, or it's a rare instance? How will its activity change further as it moves away from the inner solar system, and what remnants of matter it will leave behind? 3I Atlas is not just another comet. It is one of the extremely rare interstellar visitors. It shows us that interstellar objects can be quite different from familiar comets. Scientists are now revising how we interpret the materials of such objects, given galactic irradiation, prolonged drift. And while some speculation about artificial origins arise, an overwhelming number of astronomers find them unconvincing. Nevertheless, such discussions stimulate a revision of the boundaries of what we think is possible. The 3I Atlas observations will continue in the coming months, and there may be more surprises ahead.